Here in Keating Labs, we're going to do an experiment. We're going to see if ice made from ordinary water, that is with 2 hydrogen atoms and 1 oxygen atom, will float as well as it does on liquid water as it does on deuterium oxide, this $ per milliliter fluid that I had to special order. Let's see if the ice floating here on ordinary water will float the same way or change in some way when we try to float our ordinary ice water on top of deuterium or heavy water. Let's pour the deuterium water into this container and see if it will float an ice cube exactly the same way that ordinary hydrogen dihydrogen oxide did with ordinary hydrogen. So this is sinking and this is more, no, it does float. It floats better. So putting them side by side, here's the deuterium oxide, which is more dense than ordinary liquid water over here. And you see our calibrated ice cubes are floating better in the deuterium oxide than they are in the ordinary water, because this is more dense, this is more buoyant relative to the liquid. It will float better, so there's more of the iceberg, mini iceberg exposed here, and it floats actually better. So there you have it, deuterium oxide. Expensive, more tasty, and better for flotation purposes. But beware, it's a lot more expensive to get your hands on this water than to go down to Starbucks and get a cup of venti ice water. We're going to answer the opposite question. Does a deuterium iceberg float on top of ordinary water? Let's check it out. Keating Labs, deionized water, hashtag not sponsored. Fill up ordinary water here, ordinary water in this. And then here's my $ per milliliter deuterium oxide or heavy water. That was used to make this ice cube over here in just about as much time as it took to make these ice cubes of ordinary water. Here's an ordinary ice cube made of ordinary dihydrogen oxide. That floats just fine as ordinary ice floats on top of ordinary water. See that guy moving around? Now the question is, well, so here's the deuterium oxide ice cube. That's a little harder to get out. Let's see if that will float. This is a big boy. No, it sinks right to the bottom. Now I know what you're thinking. Maybe if it was in the other petri dish, it would float just fine. Let's try it. Take a deuterium oxide heavy water ice cube and see if it floats. It should if it was ordinary water, but no. It sinks right to the bottom. So this expensive drink on the rocks won't cool off as fast as your ordinary ice would. But be careful. Each ice cube costs about $50 to make.